One other useful feature that TCP has is it gives programmers a more useful abstraction. Now this one's kind of weird to describe, but I'll do my best. So far, when we've thought about lower layer network protocols, we've always been thinking in terms of packets. In other words, if you look at the network, it's a lot of packets flying across the network, and there is no relationship between any of the packets. So for example, if you're a router at layer 3 and you're running BGP or something, you don't really care if any of the packets are related to each other. You receive a packet, you send it off toward its destination, and later you receive another packet and you send that one off toward its destination, and you receive another packet and you send that one off toward its destination. From your perspective, the packets have no correlation at all, and you can handle each one individually. So that's what we would call a packet abstraction. You're thinking in terms of individual packets flying across the network, and there's no relationship between any of them. Now, if you're someone writing a computer program, so you're on your computer, you're writing a piece of Java or Python code, and you want to be able to connect to the internet, say you're writing some sort of app and you want it to talk to a server, well then, if we're working in the packet mindset, like you're working directly on top of layer 2 or layer 3, then your code is responsible for thinking about packets. Your code has to manually build individual packets, and it has to reassemble those packets on the recipient's end. That's something you could do, but it's kind of annoying. Imagine if you had a message you wanted to send, and you had to split the message up into your own packets, and then whoever's receiving it, their code has to reassemble the packets. That's kind of annoying, and it's not something that most programmers want to do. Now, what TCP does is it allows programmers to stop thinking in terms of packets and start thinking in terms of byte streams or connections. So now, instead of thinking of individual packets flying across the network with no relationship whatsoever, we can now think in terms of a persistent connection. In other words, there are two people that are constantly exchanging data, and we don't have to think about individual packets or how they fly across the network. We just think of this pipe that connects two people, and anytime you want to send data, you shove data into the pipe, and it appears on the other end for the recipient to see. And if they want to send you a reply, then they will shove data into the pipe, and it shows up on your end in the other direction. So now, instead of thinking of individual packets that fly across the network that you have to build and reassemble, you can imagine there being this stream. Sometimes we like to think of it like a pipe that connects two computers, and anytime you have data to send, no matter how long it is, you just shove it into the pipe, and TCP will make sure that those same bytes come out of the other end of the pipe in the same order with guaranteed delivery. So TCP abstracts a lot of the network details away from the programmers. So instead of thinking of individual packets and reassembling and how to provide reliability, you just start a TCP connection that gives you the pipe, and then you just shove data into the pipe, and you know it's going to appear on the other side. That's a much more useful abstraction for most people writing networked applications. It's much nicer to think in terms of byte streams. So this is another benefit that TCP has. By doing all of the hard work of splitting up packets, resending packets, stamping packets with numbers, TCP takes care of all of these things so that the programmer doesn't have to, and they get this nice abstraction that they can think about instead. So now someone writing a program, and that could be you, no longer has to think about how to put things in order, how to stamp numbers on the packets, how to make sure that packets arrive with acknowledgements. None of those are things we have to think about because TCP is going to do it for us. So that's something you can think about as a programmer, or the two different types of abstractions. Having said all that, we right now are going to be the TCP designers, so we have to think about these so that the programmers above us don't have to think about them.